All right, the moment we've all been waiting for. I've got a lot of equipment in, and I'm gonna see if this thing works. So remember, I got this genuine Belden 9880 cable, which is Thicknet Ethernet cable, and I still do not have connectors that will work for it. I did get a crimper. Crimper is not anywhere within reach right now, but didn't work, so that's out of the question. So then I ordered this, I think it's called LR400. It's pre-terminated with N-type connectors, which are the same type of connectors used for 10Base5. I am fairly certain that this cable was not intended to be used with Ethernet because you know, why would you? I think that the actual intended use of this is for like ham radio sort of things. It is, I think this is about 6 feet of cable if I were to stretch it out. It's not really a multiple of 2.5 meters, it's about 2.5 meters. So I'm hoping that there's enough slack in the Ethernet standard to let me use this and kind of get away with cheating on the 2.5 meter mark, because I don't have new connectors to terminate it, and this was professionally terminated. Also, I looked up the specs. Now, I'm not an electrical engineer, I'm a computer scientist by training. It says that this has a lot less loss than the original Belden cable, if I'm reading it right. Again, non-electrical engineer. You RF people out there could probably correct me, and please do in the comments. But it seems like this LR400 is a newer type of technology and has better tolerances in terms of signals and things like that. So anyway, so here's the two transceivers. So I'm going to connect them using this cable. Trying to make sure I connect it well and not cross-thread it. That would be bad. So that worked. And my intention is to take the two transceivers, connect them together with this thick piece of coax, and then terminate them, and then connect them to each of these switches through their AUI ports. So this StarLand 10 network has an AUI port, and the back of this 3Com FMS2 also has an AUI port. So I'm going to terminate this. I'm going to put this terminator, like I said, which is just a 50 ohm resistor, on the end. And I'm going to take the other end of this and connect it to this one. And I know every single time you see a 10Base5 network, people will kind of complain about how hard it is to work with the thick coax. And they are right. This stuff is stiff, and it bounces, and it moves like a spring, and it's like bends and stays in place and stuff. But it is not easy, and it will like spring around and like hit you in the face and all sorts of bad things. So, all right, so now I've got terminators on both of the ends, and if I had a third transceiver and another piece of cable, I could probably do that, but I don't. So these are the AUI cables. Remember I said I got the screw-on ones instead of the slidey connector ones. I don't like the slidey connectors, and I didn't try very hard to find them. So I'm just going to put these in, and they're just going to snug the fit. Fortunately, this is not a production network, and I wouldn't do this on a production network, and probably wouldn't be building a production network based on 10Base5 anyway. So here you go. So I'm going to connect that, and that one's going to go into this StarLand 10 connection. And I'm going to take the other end, and I'm going to connect this to the back of the 3Com router. So let me connect the AUI cable here. And I'm going to plug this into the back of the 3Com router, or 3Com hub. Alright, so now the only thing we're missing is power and some data to go across this network. So let's get some power cords. So I'm going to power up the Starland hub. And then I'm going to power up the 3Com router, or 3Com hub. You know, I used to look at the different people online building these 10Base5 networks and thinking, you know, it looks so awkward. But the reason it's so awkward is because you really don't have a choice in the matter. So, all right, let's put the power on, see what goes here. All right, this 3Com hub has a management port that takes a second to boot up. That's why it's red. This cable is falling out, so let me move this up a little bit. So, and it is just awkward technology. It's not like nice and elegant like 10Base5 or 100Base5 or 1000Base5 or whatever. And it just slides all over the place. And like I said, these cables are super springy. So everything's booted up, and there's no data at all going across this network right now. So when there is data, you would expect to see some of these lights light up, but right now they're just indicating that there's power. So not very exciting yet. So the next step is I'm going to take this this computer. So this computer down here has a 1000Base5 connection on it, and I'm going to plug it into this hub. So we're starting to see some traffic coming out of that thing. It's probably doing a DHCP request, even though there's nothing for it to get an answer to. You're seeing a little bit of traffic being generated by that NIC right now. It's not going anywhere because there's nowhere to talk to it. And then I'm going to take this connection, which is connected to this TP-Link 1000Base5 switch, and just going to plug this in here onto port 2. So you're seeing link light here, which means it is talking to the TP link, and the link light here, which means it's talking to this computer. So and we're starting to see traffic going across. So you can see like receive lights coming on here. We're not seeing any collisions yet. Now, a collision would be an indicator that both sides are trying to talk at the same time. So we're not seeing that. And SQE is off. SQE is as far as I understand, is a diagnostic mode. You usually want to have it turned off. These were shipped with SQE turned on. There's a switch inside that you have to open up the box to turn off. Otherwise, it does some extra stuff and it negatively impacts your bandwidth. So everything we're seeing right now is good. Power, lights, blinking lights, all that is good. But the proof is going to be in the pudding, and can we actually get packets across? So I'm at my Linux prompt, and I'm on a computer other than the one that is the one connected through the 10Base2. So I'm sorry, 10Base5. So I took the computer that has 10Base5 on it, and I started an iPerf server. So I'm going to hit that computer with an iPerf client, and let's see what type of throughput we get, and hopefully we get some. Well, let's try that again. So we're doing iPerf TCP, and that's not a thrilling throughput. So okay, 7.2, 7.32. I would expect something closer in the 8 megabits per second range. I'm not thrilled with that, but honestly, that it is getting traffic across, so that's a pretty big deal. Let me try it again, just to see if I get anything better. All right, yeah, 8 something is where I really would be expecting it, so this is kind of low. Not really sure what's going on in terms of why that's so low. So I'm going to run this again, but instead of instead of doing this, well, I'm gonna show you what the transceivers are doing while I'm running this. So I'm running this now with a kind of a 30-second interval, and I'm going to run this again, and I'm going to take another video of the transceivers and show what they're doing while this is running. And we're getting, fairly good throughput. It's been to 6 or 7.5 megabits per second, which is honestly not too bad, considering the equipment we're using is, probably dates from the 1980s. So let's show you what is happening on the transceiver end. So as you can see, these transceivers are going crazy, and they're getting a lot of collisions. So these collisions are generally, bad things. So every time there's a collision on non-switched Ethernet, both sides back off for a random amount of time and try again, and sometimes that random amount of time ends up being the same amount of time, which means that they collide again. But we're seeing a lot of collisions, which is, not great, but the fact that we're getting pretty reasonable throughput is pretty nice. And you see a lot of activity here, and this amber light is an indication of activity on the 3Com. But this, honestly, has been really successful. I'm very happy that this cable, which is probably not intended to be an Ethernet cable, is working well. And I'm going to call our 10Base5 network a success. So the next step is going to be to grow this into a 10Base2 network, which is going to use a thinner version of a coax. So thank you so much. Please like and subscribe if you want to see more of these. Please comment. I am dying to know that other people are watching these, and we'll go from there. Thank you.